Now we will discuss method of size exclusion chromatography. We'll see how this size exclusion chromatography is performed. So size exclusion chromatography is performed with a column which consists of hollow tube which is tightly packed with beads, and these beads have pores of different sizes, and the size of the pores that are selected according to the components of mixture which we want to separate. If we want to separate the smaller molecules, or if the components of mixture which we want to separate they are smaller, then we select small size beads which have small pores in them. And if we want to separate larger molecules, then we select beads which contain accordingly larger pores in them, so that those can be separated. These pores, they are depressions on the surface or channels through the beads through which separation of components of mixture takes place. And as the solution travels down the column, some particles enter into the pores of the beads, while others, they do not enter into the pores, or if they enter partially. So this partial entrance of the components of a mixture into the pores of the beads that result in their differential separation. जाहिर है जो मॉलिक्यूल उसमें सेपरेट जो उसमें एंटर होते हैं, पेनिट्रेट करते हैं, वो अलग एल्यूट होंगे, और जो एंटर नहीं होते वो अलग टाइम पे एल्यूट होंगे. और यही जो डिफरेंशियल एल्यूशन होगी ऑन द बेसिस ऑफ साइज, यही उनको सेपरेट करने का बायस यही बनती है. Larger molecules, they simply pass by the pores. They do not enter the pores of the beads. They travel through the distances or through the spaces between the beads, and those molecules which are too large to enter the pores in the beads, they simply pass rapidly through the column. Larger the particles, the faster will be their rate of elution, while smaller the particles, smaller the molecules, the longer will their retention time. जाहिर है उन्हें ज़्यादा longer path से travel करना पड़ता है, उनकी उसी तरह से retention time ज़्यादा होगा, और इसीलिए वो slowly उसमें से elute जो होंगे. And this all depends on, if all the particles, these are loaded simultaneously, and when they are loaded simultaneously, then particles of the same size, they elute together. ज़ाहिर है अगर different type पे load करेंगे, then we will have different results. They have to be loaded simultaneously. Analyte does not normally interact with the surface of the stationary phases. Generally, जो हम components mixture के separate करना चाहते हैं, they do not react with stationary phase, and if they react with stationary phase, then there may be interference with the result. Differences in elution time between analytes are based on the solute volume. Small molecule can penetrate every region of the stationary phase pore system, which is equal to the sum of the entire pore volume and the interparticle volume. That's very important, and that is why their elution will be differential. A larger molecule that cannot penetrate smaller pores, they will enter only the interparticle volume or interbead volume, and they will accordingly elute earlier. So particles of different sizes, they will elute through a stationary phase at different rates, and this results in separation of the solution of the particle, which is based on their size. There are various measures of size of the molecules in the sample. There's various size of the macromolecules in the sample. A fundamental problem in size exclusion chromatography has been the choice of proper molecular size parameter by which molecules of different kinds they are separated. हमने पहले भी डिस्कस किया कि जो बीड्स की सिलेक्शन होती है, जिनके अंदर पोर्स की वजह से कंपोनेंट सेपरेट होते हैं, किसी मिक्सचर के कंपोनेंट सेपरेट किए जाते हैं, वो बड़ी इंपॉर्टेंट होती हैं. और उनकी जो प्रॉपर सिलेक्शन होती है वो बड़ी इंपॉर्टेंट होती है. उसी की बेस के ऊपर डिफरेंट कंपोनेंट मिक्सचर के सेपरेट होते हैं. An exclusion limit defines the molecular weight at the upper end of the column according to which separation takes place, and molecules too large to be trapped in the stationary phase, they are eluted from the column accordingly.